Hello everyone and welcome to the channel and welcome to another video of cheat sheet series. In this series we are taking short videos, crisp videos and trick oriented videos in which you can apply certain tricks to solve a particular type of question. Alright, and this video is about Maxwell relations. Now whenever we discuss about thermodynamics, the most difficult part of thermodynamics is formula. So many formulas are there, so many so many things you have to memorize. So that's where this video is going to help you. Today in this video we'll see quick tricks to solve Maxwell relation or to find out Maxwell relation. After watching this video, you don't have to remember any Maxwell relation. Okay, you can yourself derive it or you can yourself create them in the video exam and in very less time. Okay, so you just need to know certain tricks, certain mnemonics how you can do that. Okay, so it's just a trick which is going to help you to find out all the Maxwell relations. Okay, now when we talk about Maxwell relation, these are the major types of Maxwell relation which are going to come across. There are around 16 equations which are over here. By the end of this video, till the time this video will end and you will understand whatever I have explained in this video, after that you don't have to remember any of these equations which are written right now on the screen. Okay, all these equations you can create yourself or you can make yourself just by using these tricks. All right. So let's get started with it and let's get into the video. Let's try to understand that how you can make all these equations very easily, very quickly, just by using certain tricks. So let's get started. Okay, before going into the trick, just a quick update about the terms which you are going to come across throughout this video. You are already familiar about it, but just a quick just a quick overview of it. So P represent pressure over here. So throughout this video, P will represent pressure, T is going to represent temperature, S will represent entropy, V as usual it is going to represent volume. All right. So these four terms are going to represent the properties. Then similarly, H is going to represent enthalpy. So these are now all the energy terms over here. Okay, U is going to represent internal energy, and G is going to represent Gibbs free energy, and then your F is going to represent Helmholtz free energy. Okay, so now once you are okay with it, once you have understood that what these terms actually denote, now what you will need is extended, or you can say double thermodynamic square. Okay, that's what I call it, you can call it anyways. So this is how it looks. Okay, so this is nothing but a square, basically a square inside a square, that's what it is, and what we call it is a double thermodynamic square. Okay, double thermodynamic square. Now how to use this square? Before going into it, let's try to dig into let's try to look upon the different part of it. Okay, so first thing is that we have this internal square which is nothing but S, P, V and T. This is what we have. Now this is called as internal square or the smaller square. With this you can find out the basic Maxwell relations. Okay, so basic Maxwell relations can be calculated using this. Now how to remember it? How to remember this? It is pretty easy. Okay, you have to remember one phrase which says that Satya Prakash very talented. Okay, so if there is anyone whose name is Satya Prakash, please do let me know in the comment section. Okay, so S for Satya, P for Prakash. So Satya Prakash, V for very and T for talented. So Satya Prakash very talented. Now you don't have to make this mistake because many people write it like this, Satya Prakash very talented. No, it's not like this. Okay, you have to go like this line by line. So Satya Prakash in a single line, very talented in the other line. Okay, so this is what you have to take care of. So this is one thing which people do mistake, and if you do mistake, everything is going to get blunder. Okay, so you don't have to make that mistake, be very careful with it. Now this is one of the square. Now out of, or you can say the outer square is made up of the energy terms. You have to start from enthalpy. Okay, so just remember the word hug. Okay, just the word hug, H U G. and at the last you will have just one term, that is S. So just join them, and this is how your thermodynamic square is now created, or it is made. Okay, so yeah, so you have just got your thermodynamic square like that, double thermodynamic square. Now let's try to look upon that how exactly you have to use it. Now we have just understood that how to make it, okay, or you don't have to remember this as well, you can just make it in the exam quickly. Now how to use it, okay. So as I told you, there are different set of equations. Let's try to look upon that how we can actually use them to find them out. So first of all, I will tell you for the Maxwell equations. These are Maxwell equations, and for them you don't need actually the extended or the double thermodynamic square. You only need a single thermodynamic square, and I guess most of you know about this trick, but in case if you are not aware about it, I'll explain you, okay. So the basic equation or the basic thermodynamic square can be done like this. So let me write it down. The internal square I just need, okay. So S, P, V and T, okay. I'll add all of them. Let me change the color. Yeah, so now I have this, okay. What you have to understand is you have to start from any parameter, okay. You can, let's say I am going to start from S, which is entropy. So since I am starting from S, I will write down del S. Now where I am going to P, or from S I have reached to P. So I will say del S by del P, okay. So from where you have started, you will write down del S of that, where you have reached del P, and then you will go across like this, like you have to travel till 3 parameters in any direction, in clockwise, let's say I am going. So del S by del P, and this T tells you that it is going to be at constant T, okay. Now one thing again you have to see, that you have to make an arrow inside of this, okay. That arrow has to be in the diagonal direction from the first character, or from the first letter to the last from where you reached. So you started from S, you reached to T, so that means the arrow is going to go in the downward direction. Now one thing which you have to remember, that downward arrow is negative in sign, and upward arrow is going to give you positive sign. So which direction this arrow is going? This is going downward, so that's why you will get a minus sign in front of it. That's it, okay. Now again I'll change the pen just to make it clear. Fine. Now what you have to do, in order to write down the other part of this equation, you have to start from the variable which is not yet used. So you have used S, you have used P, you have used T. Which you have not used out of 4? You have not used volume, right? So you have to start from that. So this is what you have to remember. One part when you have written, the other part will be written from the parameter which is not yet used, okay. So V is not used, so this is going to start, like we have to start from del V. And now in which direction you have to go? You have to go in the opposite direction of from where you were going earlier. So earlier you went from S, P, T, that was a clockwise direction. Now you have to go in a reverse direction, which is in the anti-clockwise direction. That means you will go in this direction like this, and you have to go till 3 parameters like that. So you start from V, you went to T, so del V by del T, and where you reached to P, right? You reached to pressure, so at constant P. Now this side you have to again make the arrow in that diagonal arrow inside the square. That diagonal arrow should be made from the first alphabet to the last, and that arrow is going upside, so that's why the sign will be plus, or if you don't make any sign, that makes it plus, and they will be equal to each other. So this is first Maxwell relation which you have. Del S by del P at constant T is equals to del V by del T at constant P with a minus sign. So this equation, if you see, so if you match it up, so you have just found this equation, okay, you have just made this equation. Similarly, I'll just give you one more time, because I know in one go it is very difficult to understand, or you might have skipped few things. So just for that sake, I'm just going to make it once again, okay. So what I'm going to do, first of all, I'll make that square. So I just need this internal square, that is S, P, V and T. Once I have made it, now I will use a different equation to do that. Let's say I am starting from P, okay. So I am going in, let's say, in this direction. So this will be what? This will be del P. Then where I reached from P, I reached to T. So I will say del P by del T. And what will be constant here? I reached at the end to volume. So that's why volume is going to be constant. tell me the sign of the arrow. Since this arrow has to be made from the first letter to the last letter and this arrow is going downwards, I told you already that the downward arrow is going to give you negative sign. So that's why you will have minus sign here. Okay. Now what's next? You have to make the other part of it. For that you have to use the parameter which is not yet used, that is s, and you have to go in the reverse direction. So earlier you were going here, now you have to go in this direction like this. All right. So you started from s, so del s, you reach to v, so del v, and what will be constant here? Constant will be t. So at constant, arrow will be again downward because you have to make arrow from the first letter to the last letter. So from s to t, the arrow is going downward, so that's a minus. This will be the relation. Basically, if you have both side minus minus, so they are going to get cancelled out. Your equation will be del p by del t at constant v is equals to del s by del v at constant. Let us look at it quickly. Do we have this in the Maxwell relation? So yeah, this is the equation which we have just derived. So I'll recommend you to try these equation. Okay, these two, just try it out using this small square. This is very easy. Okay, this is very easy to do. So I hope you all will be able to do. So this is one set of equation. By this you will be able to find out 1, 2, 3, 4 relations. 4 relations can be done very easily. Now for the other 12 relations you need the extended one, okay, or the extended thermodynamic square. So let me take you. So now what we want is to derive these equations which are Legendre transforms, okay, the definitions of internal energy, enthalpy, Gibbs free energy and Helmholtz free energy. Let's try to do that. So we will again use our extended thermodynamic square to do it. Let's see it. All right. So in order to do that, what you have to do? You have to basically make a arc, okay, or you can say a semicircle. That's what you have to do. So how you will make a semicircle? Let's say I want to start my semicircle from G. So this is how the semicircle will go, right? This is the semicircle which it is going to go. So now you have to break out this semicircle in steps. So how you will do that? You are actually going from G to T, then you are going from T to S, and then you are going from S to H. All right. So how you will write down? See, you will write down G. Okay, you will write down G because you started from G. Then you will write down these two as products. That means TS. Okay. So you have written G and then you have written TS. Now this is again the smaller square which we did earlier, and this arrow is the diagonal arrow of that. So this arrow is going upside. Rule is same. If the arrow goes upside, plus sign. If the arrow goes downside, minus sign. So since this arrow is going upside, you have to apply plus sign, okay, in front of that. So TS will be plus and is equals to H. So you have just found a equation for enthalpy, or you can say that G is equals to H minus TS. Okay, both these equations are correct. So this is how you can simply calculate equation for the Legendre transforms. Okay, let me tell you one more. Okay, now just look upon the green color pen. Okay, so let's say I want to find out equation for my internal energy. For that I want to relate it with enthalpy. So this is how my semicircle should go, right? So from where I started from U, that is internal energy. Then these are what? This is Vp, right? This is Vp. Now since this arrow, because from V to P you are going in the upward direction, right? This is how you are going. So that's why the sign is going to be plus and this is going to be H, or you can say that H is equals to U plus PV, right? This is what is the definition for H, basic definition. You can also form the differential forms of it. Okay, so this is how you can calculate this equation in all the forms. Like you can calculate the equation for F as well, you can calculate the equation for G, and this is how you can relate all of them. Now let's see the differential equation. So these all 4 equations you can simply do. The next thing which we are going to look upon is the differential equations, okay, which will go in the form of del, like del U and del V and something like that. Okay, so let's look upon it, how to use the extended thermodynamic square to find out these equations. Okay, so let's say that I want to find out the differential equation for internal energy. Okay, so whatever equation or whatever term you want to find out, you just circle that out first of all. That means I need to find out the equation corresponding to du. Now from where you have to start? You have to start from the things which are in front of it. Okay, you don't have to start from S and V. You have to skip that and you have to go to the next thing, that is T and P. So you have to start from T and P. Okay, and the rule says that you have to always go in the diagonal direction inside the central square. So you always have to move in the diagonal direction. So this is going to go in this direction, this is going to go in this direction. So if you are going upside, okay, so this is what you are starting from T and you are going to S. So you will write down it as T ds, because you started from T and you went to S. So T ds. What sign it will be? Because the arrow is upside, so plus sign. Okay, so I am not writing any sign here. If you don't write any sign, that also means it's a plus sign. Okay, then you started from P and you went to V. Okay, so what you will say it? P dV, because you started from P and you went to V. So P dV. What sign it will be? Because you are going in the downward direction, that's why you will write down minus sign here. And since both of them will go to U, so that's why del U is equals to T ds minus P dV. As simple as that. Similarly, you can find out other equations as well. I'll show you one more. Okay, now let's say I want to find out equation for Gibbs free energy. Where you have to start from? You cannot start from P and T because they are just adjacent to it. You have to start from S and V. Alright. Now first thing is that you have to write down the one which is going like this. So you will write down del G first of all, because that's what we are doing. S to T. So this will be S dt, right? Because you started from S, you went to T. So S dt. Arrow is in the downward direction, and because the arrow is downward direction, you have to write down minus sign. So minus S dt. Then V to P you are going, so this will be V dP. And since the arrow is going upside, so that's a plus sign you have to write down. So basically you got an equation that del G is equals to V dP minus S. As simple as that. You don't have to remember this equation. Similarly, you can find out equation for enthalpy as well. For enthalpy, like similarly, if you will do, you will find out the enthalpy for you will find out equation for enthalpy, that is going to be T ds and plus V dP is equals to del H. Okay, try it out. Okay, try it out and see whether the other equations works or not. So basically what we have done is we have calculated the differential equations. I have done this one and this one for you. You can find out the other two as well. Okay, so we have done this set of equations, we have done this set of equation, and we have done this set of equation. Next thing which we are going to do is to find out or to compute the variables. These type of questions are asked directly in the exam, where they ask that this particular, like they will say ki del H by del S at constant P has unit of what. Okay, so in that case this is going to come very handy. Again we will use the same extended thermodynamic equation to find this out. So let me show you how it will be done. Alright, so how we are going to do this? Let's say that I want to find out the value of temperature. Okay, I want to find out temperature. So temperature will be equal to, what you have to do now? You have to make a arc like this. It is called half arc. So what you have done just now, you went to S and then you went to H. So finally where you reached to H, that is enthalpy. So where you reached finally, that you have to write down del H. Through which way you reached through S. So you will say del H by del S. Something must be constant here. So what will be constant? The term which is on the this side, which is pressure over here. So this pressure is going to be constant. So the term which is towards that arc, the term which is like in the concave part of that arc, that term you have to write down. Now again I told you that this arrow is going to tell you the sign. So since this arrow is going upside, so upside arrow gives you positive sign, so you can write down plus, or you don't have to write down any sign. Then one more equation you can write down with respect to T. Why not this arrow is going in this direction? It is also true, right? You can move this arrow in this direction as well. That is also correct. You can write down this again is going to be where you reached to internal energy, that is del U. From where you reached, like through what parameter you reached through S, right? The S was the way. So del U by del S, and what will be constant now? The term which is towards the arc, that is V. So del U by del S at constant V, and again the arrow is in upward direction, that's a plus sign. So both these terms, del H by del S at constant P and del U by del S at constant V, both of them will give you the value for temperature. Let us just quickly check it out whether it is correct or not. So yes, it is correct with respect to temperature. Let's try to find out for the entropy, and let's see whether equations hold true here or not. Okay, so again I'll show you with an example. Let me draw this square. Okay, all right. So now, as I said, I want to find out for entropy. So I will say entropy, that is S, is equals to, what I have to do, I have to make a arc. This arc can go in this direction also, and this arc can go in this direction also. Let us do one by one. First, my arc is going towards Helmholtz free energy. So where I reached at the end, I reached to Helmholtz free energy, that is del F. Through which parameter I reached? I reached through temperature. So del F by del T. And the arrow is in downward direction, right? This arrow is in downward direction. That's a minus sign. And what should be kept constant? The one which is towards the arc of it. So that is V. So del F by del T at constant V. Remember that in chemistry we can also represent Helmholtz free energy as A, as work function. So that is also true. In some places you can express this as capital A also. Okay, so don't get confused between that. Helmholtz free energy is F. That is what you have to remember. One more thing you can do is that this arc can turn in this direction. That means now you have reached to Gibbs free energy, that is del G, and through where you reached through temperature. What will be kept constant in this case? So your pressure is going to be kept constant. And what will be the sign of this arrow? Because this arrow is going downwards, so minus. So entropy will be equal to minus del G by del T at constant V. So you got the equation for entropy as well. In the similar way, you will be able to find out the equation for pressure as well, and you will be able to find out equation for volume as well. So these set of equations which we have seen here, we have just found this one. Okay, so you can simply find out all the set of them. So try the other ones as well. In that way, you will be able to practice the equations also, and it will be easy for you to do in the exam. The last set we have to do, that is differential equations for U, F, G, and H at variable amounts of matter. This is where the where your Gibbs to Hem equation and all comes into play, where your chemical potential comes into play. Okay, so here mu I is the chemical potential of the ith particle, and yeah, so let's look upon it. So what you have to do in these equation, you have just understood how to find out differential equation. Okay, I have done these two. I'll just quickly do for del H, okay, just for the sake of video, so that you just understand it once again, and then I will show you how to do this part. So now let's say I want to find out H, okay, or the value of differential equation for H. So from where I have to start? I told you that you cannot start from the adjacent ones. You have to start from the parameters which are little away from them. So you have to start from V and T. From V if you go, so it will be V, what you will say it? You will call it VdP, because you started from V and you went to P. So VdP. What will be the sign? Sign will be plus, because the arrow is going in the upward direction, right? So VdP. And then this is from T you are starting, so T, and you are going to S, right? You are going to S, so it will be TdS. Sign is again going to be plus, because this arrow is going in the upward direction, and both of them are going to give you the value of del H. Now once you have found the value for this, when you have to write down in the terms of chemical potential, or the extended formula of it, or for the variable amount of matter, you just have to add this parameter, that is sigma mu I dni. That's it. Okay, so if you have remembered, or if you remember if you have just found the differential equation, you just have to add this parameter to make it for the variable parameters. I'll just show you once again, okay, so that you don't get confused. See, all these equation, du is TdS minus PdV, here also du is TdS minus PdV plus this parameter. Then here dH is minus SDT plus VdP, dH is minus SDT plus VdP plus this parameter. So in all of them, if you see, this parameter is added, that is sigma mu I and dni. So that's what you have to do in the differential equations. You just have to add this parameter to get equation in terms of chemical potential, or to get equation for the variable amount of matters. Now these Maxwell relations, or whatever equations we have just seen, the trick to find out these equations, they are used in various various ways. They will be used to find out thermodynamic equation of states. They will be used in the derivation of Cp minus Cv for real gases. They will be used in the derivation of Joule-Thomson coefficient. So many places these equations are actually used. So that's why it becomes very important for you to actually do these Maxwell relations quickly. All right, that's it for this video. I just thought to make this one so that you get benefit from it, so that in the upcoming exam it will be easy for you. At least if you get any question from Maxwell relation, you will be able to do it. It will be super simple for you to do, right? Thank you so much for watching. These are my social media handles, like for this particular channel. We are on Facebook, we are on Instagram, we are also on Twitter. You can also follow me on Instagram. The handle is right in front of you. Thank you so much for watching this video, and do let me know if you guys like this type of videos. I'll try to make more videos of cheat sheet series in the upcoming days. That's all from my side. Thank you so much for watching, and I will see you in the next one. Till then, have a great day. Bye bye. Take care. Hey guys, so I teach live on Unacademy Plus platform. Here I teach for the CSIR-UGC-NET category, and you can follow me over here for regular classes. You can access my free classes as well as my paid classes on this particular platform. The classes which are free, you can get that under the section of special classes, whereas in order to access my paid classes, paid live classes, you have to take Unacademy Plus subscription. So do make sure that you take the Unacademy Plus subscription to access all my paid classes, which are quite organized. The whole syllabus is being completed over there, and the classes are quite regular over there. So make sure that you take Unacademy Plus subscription by using my referral code, that is N_Huda. That's it for this. Thank you so much.